Hello, welcome back. I'm still Matt McSpirit.
I'm still Corey Hines.
Excellent, and we are back for the next module in the course. So let's look at virtualization specifically and some of the new features and functionality that's in the next release.
Let's go.
So what are we going to cover in this module? Well, we're going to look at, as Corey said before we even got to the intro, we're going to look at the story so far, ground you in just some of the stuff that was introduced in the current, I keep saying the previous version as if the 2016 is available, but the current version, Windows Server 2012 R2 Hyper-V. Then we'll dive into the key areas of enhancement, so security and isolation, big improvements there, real game changers for service providers and large enterprises as well. We'll look at availability, clustering, new features there that can enable you to stay redundant and keep those workloads up and running and continuously available as possible. We'll look at something that pains people worldwide, upgrades, moving to the next version. How can I keep up at the rate of change that Microsoft is bringing to market, new releases? And then finally, this last category is a catch-all for just stuff that we didn't know how to classify. It's kind of cool and handy stuff that just makes your life as that multifaceted administrator.
I wanted you to name that bullet just fun.
Fun.
Because that's where all the fun stuff is.
Yeah, Corey Hines likes this.
I do.
Yeah. We can use the term fun if you want. We'll use driving operational efficiencies for the time being, but we may go to fun. We'll let you be the judge, actually.
It's the accent. He's against fun.
Oh, no, that's not true. Security. Right, so the story so far, where are we up to? What have we introduced with Hyper-V in 2012 R2? Firstly, from a scale perspective, I'd be intrigued to understand if people at home or people watching at work in their environments have actually hit these scale limits.
So if you have, raise your hand.
Yeah, show of hands.
So there's at least 3.
Yeah.
And one of them's the AV guy.
Yeah, it's Danny. He's both hands. These are big scale limits for virtual machines. I don't think we're in a position where we need to worry about, okay, this is the ceiling for Hyper-V, this is not big enough for my workload. So when you think about 64-way virtual machines, you think about 1 terabyte of RAM per VM, 4 terabytes per host, lots and lots of logical processors per host, lots of VMs per host, and features like virtual NUMA, which is when you start to create multi-processor virtual machines with large amounts of memory, the efficiency of balancing that on a large system really drive higher levels of performance.
The other thing you kind of start to find, you reach a point where the host gets so big, it's too big a risk.
Yeah.
That's ultimately a host is a single point of failure, period.
Yeah.
And it gets so big that the host becomes too much of a risk. So I think a lot of people resist scaling mass, and try to distribute a little bit at some point.
Just because you can.
And you'll notice that, Microsoft are not out there pounding the drum about how big Hyper-V can go anymore, because it's kind of, it's reached sort of a reasonable level, if you consider this reasonable, a reasonable level where, it's at the point that the scale's not really a blocking issue anymore. Now it becomes, how do I make it more secure? How do I make it more reliable? How do I eliminate reboots? Yeah. And you'll hear that a lot, eliminating reboots. Yeah,
that's a good point. And some of it does come down to testing. I mean, the availability of systems with 8 terabytes of RAM, 12 terabytes of RAM and beyond, they're not as readily available, and they're probably very expensive. So at this point, well, quite expensive. In that respect, do we need to...
He's never had to buy them. He's had someone buy them for him. I've had to buy them. They're freaking expensive.
That's why we bring you on, for real-world experience.
I know. I've got a 64-terabyte laptop right here.
The 64 terabytes. There you go. Yeah, all right. So when we think about agility, you think about moving virtual machines around. You think about scaling virtual machines up and down as efficiently and as automatically as possible. And that's where features core in the box like dynamic memory, live migration, enhanced with live migration with compression, or using SMB networking and RDMA to really accelerate live migrations at light speed. That's phenomenal performance for those kind of operations. And being able to migrate all of your virtual machines a lot quicker, you might think, well, live migration's live migration. What does it matter if it's faster? But if you've got a decent sized host where you've got a decent number of virtual machines running on there, and you need to perform some form of maintenance on the host, whether it's patches and reboot or whether it's some kind of hardware maintenance, getting those VMs off and distributed onto other nodes within your environment is still a time-consuming exercise if you've got a lot of VMs. The faster it does it, the quicker you get that job done.
We've had scenarios in our own infrastructure where we've had a host report errors. We want to evacuate the host, and we've live migrated to empty the host. And when you're running, a couple of hundred gigs of running virtual machines, I mean, it's a couple of hours to get everything migrated off. Quick migration is technically faster, but requires downtime. Yep. So anything you get in live migration that lets you evacuate faster is good.
Is a good thing, yeah. And that was complemented by storage live migration, combine live migration with storage live migration for shared nothing live migration, moving the disk and the VM's running state from one place to another very flexibly without anything but a network cable. So no shared storage required for that.
And the scenario there, by the way, if you've never run through it, is, I've got a VM on my laptop and I'm a developer and I build something and I want to get that in production. I can go from my laptop to the test server in the data center to the production cluster with all the disks on shared storage and CSV without ever turning the VM off.
Yeah, assuming you've got connectivity all the way through.
Obviously.
Yeah.
But that's probably not a real realistic scenario, but you can actually do that. And I've done scenarios.
Especially if you've got a 64 terabyte laptop. So when we think about resizing storage, hot add, resize of the virtual hard disk, storage quads, which you'll see some significant enhancements for today, live exporting the virtual machines, these are all features that really add extra levels of agility to Hyper-V. When we think about clustering and high availability and keeping your workloads running, host clustering, 64 node clusters, guest clusters, so workloads that are running on the platform that need clustering, using shared virtual hard disks, which are a real benefit for guest clustering, makes it so much easier.
Shared VHD is one of those little features that gets overlooked, I think, because if you're a multi-tenant hoster type scenario, and you want to do a guest cluster, such as SQL clusters, Exchange clusters, et cetera, without shared VHDX, you have to take your storage fabric and you have to plumb it. You have to break that seal between guest environment and fabric environment and plumb storage through that seal. And that creates all sorts of dependencies and issues and considerations. With shared VHDX, you can do guest cluster without breaking the seal or crossing the boundary from physical fabric, physical storage to virtualized resources.
Yeah, and that's a big consideration, certainly for service providers, also enterprises as well. And having shared VHDX, even if it's an enterprise environment, not a hoster, it's streamlined the deployment because you can use things like templates in System Center that contain that shared VHDX, so you can deploy these clusters
I would argue that
flexibly.
In large enterprise environments, with the way technology is today, you're kind of thinking like a hoster anyway.
Yeah, good point. So when we think about networking, network virtualization integrated, you'll learn a lot more about that this afternoon or later in the morning, depending on where you are, or at night. Network virtualization
in
gateway.
The future.
Yeah, sometime later on. NIC teaming, all of those capabilities built in the platform, which was big from a networking standpoint. It's not just about Windows guests, it's also about Linux, also FreeBSD, and we're not just talking about a tick box, yes, you can run it on the platform. We're talking the key features, the hot add of storage, dynamic memory, great scalability and great performance, VRSS and so on, exposed to the Linux workloads as well. So it's not just about Windows. And then finally, that stuff that fits into the operational efficiencies in some cases, but the and more section, maybe the fun section I should have used.
I wouldn't consider Gen 2 the and more fun stuff. Gen 2 is pretty significant, pretty important.
Yeah, you're right. Yeah,
What?
it is.
Enhanced
it is
session,
fun.
Well, it is. Enhanced session, yeah, that's fun. And more, yeah, that's fun too.
Yeah, I couldn't think how to classify it because I would have had to have two boxes. So Gen 2 VMs are the future of our virtual machine standard, our virtual machine type, and you'll learn a lot more about the stuff we're bringing in Hyper-V going forward in this module. What you'll find is that, that requires Gen 2. Yeah. That's a Gen 2 feature. So yeah, bear that in mind. And all of those just built in, which is great. So it really enables you to benefit from a lot of virtualization stuff in the box. And that's recognized both by Gartner. So when we think about from x86 server virtualization, a leader in the Magic Quadrant, public cloud services for Azure, cloud infrastructure as a service for Azure. Remember, it's that consistent platform. And when we think about Hyper-V specifically on premises, both Microsoft, a leader for 5 consecutive years, and VMware in there as well. So the two market leaders.
This is your mandatory marketing slide?
No, it's gone.
Oh,
I don't know
excellent.
what you're talking about. It's disappeared. Like a Fight Club slide. Just in and out.
We don't talk about marketing slides.
No. So first key area of enhancement is security. And it's one of those areas that is incredibly important because it's not just that we hear about it in the IT world, we hear about it on the news, on the radio, cyber attacks on the rise, malware effects from various locations across the globe. Organizations are being attacked more and more, and it's becoming more prevalent as a news story because of the impact it can have on the economy, on that business specifically. And a lot of it is to do with hackers gaining entry into the environment and stealing corporate or trusted information. When we think about the kind of risks and some of the scenarios, I think was it last week or the week before that the car hacking took place? I mean, it's an example that you probably know. Yeah, you never thought that this would happen, and yet because
there's a reason I drive a 20-year-old beater pickup truck.
Fair enough.
You can't hack AM radio.
Fair enough, with a tape deck and everything. So those kind of things.
8-track.
Oh right, sorry. Yeah. those kind of things are becoming more and more prevalent. And we have to think, how can we, from a technology perspective, with our infrastructure tools and our components that are within our stack, how can we start to protect against these kind of threats and these kind of attacks? Because they are serious and they can have a big impact. And when you think about what introduces the biggest risk, it's administrative privileges. So you'll see here, administrative privilege, phishing attacks, stolen admin credentials, insider attacks. Each of these type of attacks seek out and exploit a privileged account. So an account that's on the system that's got enough privilege, enough ability to impact a broader change.
There's an old rule of thumb, which is you have to trust your administrators, period. Yes. You have to completely and utterly trust them. And if you don't, you need a different administrator, quite frankly. But how does that translate into the world of cloud services where I'm going to take, my workload and run it on hardware that's run by an administrator who I don't even know? How do I know I trust them? And then as an administrator, how do I accept a workload from someone how do I know that that workload is not going to try and take me down? And so a lot of the security features are going to start looking at help make that more digestible. Yes. Protect the fabric from the guest and the guest from the fabric. So
yes. Yeah, exactly. That's right. And when we think about that administrator, we gave them the keys to the kingdom. So the admin is the all-powerful, all-knowing person within the infrastructure from a Windows account perspective. But these privileges, if they get compromised, whether that's through social engineering, bribery, coercion, whatever other initiatives they may be, you just have a bad day, it's the end of the week, maybe you've lost your job, you think, okay, I'm going to really stitch this organization up, here we go. They have got the keys to the castle there, and it's a big, big risk. So we have to assume breach. So we're not thinking of this from a pessimist perspective. We're thinking, okay, if we assume we're going to get attacked or we already have been attacked, we need to implement technology that A, can prevent that in the future, but stop it from spreading, detect it, and respond to the breach. And it's not just technologies that exist within Windows Server that can help us. It's also combined with System Center and our operational management technology, OMS. But today we'll focus on specifically what's going into the fabric and how we're hardening that to really enable us to prevent and try and prevent these attacks happening in the future. So when we look at some of the challenges that we face within protecting virtual machines specifically, we've got the fabric, we've got a virtualization layer, the hypervisor, we've got some storage, we've got somebody looking suspicious in front of a machine there pointing towards a ladybug? I'll call it a ladybird. Maybe it is. But
I've never seen an evil ladybug before. It's
the first time for everything.
That's awful.
But we've got this layer of fabric, and then we've got this customer layer where the virtual machines reside. And we think, okay, as Corey said, that administrator who's got all power, if they get seized or the host gets compromised, they can access, if they know how to do it, and they're using readily available tools that they could use for this process, they could attack the virtual machines. They could attack from host into guest. So we need to make sure that we're providing additional levels of isolation to really enhance that and protect against that.
That's, frankly, one of the big objections for a lot of companies in using public cloud services like Azure is, I want to put my workload out there, but it's my data. How do I know my data is protected from the Azure guys?
Yeah, exactly.
How do I know that Microsoft hired good people? Obviously they, try to, but that's the ultimate objection, and that's what this is designed to overcome, is that objection of how do we, I want to put the workload up there, but I don't trust the people running the fabric because I've never met them.
Yeah, exactly. And it's not just about the virtual machine itself in isolation, it's also how do you know that your host hasn't been compromised? How do you know that it's a legitimate host? And without hardware-based verification or without advanced verification technology and code integrity technologies, it's very difficult to see whether a host has been compromised or not.
The great thing about virtual machines is it makes it very easy to steal the Active Directory database.
Correct.
Because all you got to do is take the VM.
Yeah.
And if you're, what's to stop the fabric administrator from grabbing the VHD, taking it home and pounding away in it for a couple of days to try and get the administrator credentials. And
exactly, and we'll see a bit of that in an example in a demo. Exactly. And those tenant VMs that are running on this shared infrastructure, they're exposed, they could be exposed at the guest layer. There's nothing stopping, for instance, a storage and network attack affecting the virtual hard disk or inside the virtual machine itself. So there's multiple layers that make it difficult to protect virtual machines. But what Microsoft is introducing is 3 key areas. Firstly, a virtual secure mode, where process and memory access protection from the host and the virtual machine. So we're introducing this extra layer of isolation using hardware-rooted technology to really isolate the guest OS from the host admin. Second, this guarded fabric, or this concept of this host guardian service, which is an enabler. It's a new service we're introducing in Windows Server 2016, and we'll learn a bit more about it as we go forward, that enables you to run shielded VMs, and we'll talk about what they are in a minute, on legitimate hosts. So it's a technology that's not only allowing you to run protected VMs, but also that your hosts that are going to run these protected VMs are legitimate.
So there's a few things to be aware of when you think about this idea of host guardian service shielded VMs. It's going to leverage TPM and BitLocker, but software-based TPM and software-based
inside the VMs.
Inside the VMs.
Yes.
And then there's a mechanism for distributing encryption keys. So it's an infrastructure component that you have to design, build, and set up. So you've got services, there's an additional Active Directory forest you've got to deploy to protect all the keys. What it essentially allows you to do is BitLocker encrypt all your VMs, so that only that entity that has the keys can even boot and start and do anything with those VMs. And if you lift the VHD off, it's BitLocker encrypted. You can't get at it anyway.
Yeah, and it wouldn't be able to, if you ran it on one of your hosts in your own data center, having stolen it, it's not going to be able to communicate back to get the relevant keys to decrypt, to start up. And
so if it's on a trusted host that has access to the BitLocker key repository, I'm using sort of loose terminology here to just illustrate the concept, then that host can boot the VM.
Yeah.
If it's moved to an untrusted host that's not part of this shielded infrastructure, it doesn't have the keys, it can't even boot the VM. You can't offline mount it, you can't do nothing.
Or if it's even moved to a previously legitimate host that had been compromised.
Yeah.
If it doesn't, that host is now no longer legitimate because it's been compromised, we won't place that virtual machine there, we won't allow it to boot, so it's protected.
And this idea of it's been compromised is based on what the host should look like, signatures of files, the boot process, code integrity. Basically heuristics on what a properly configured host and a non-compromised host should look and act like. And if it matches that, good. If it doesn't, it's not good.
So Corey touched on that third block, which is a shielded virtual machine. So what is a shielded virtual machine? Well, it is that VM where the data and state of the shielded VM are protected against inspection, theft, and tampering. And Corey's going to demonstrate that shortly from both malware and the data center admin. So that shielded VM is heavily protected and ensuring that we don't access it or malware can't access it because it's protected and encrypted. When we think about how we protect that in a little bit more of an architectural view, there's a lot more components. So we saw this view before where we've got the fabric, logo certified hardware, TPM version 2 inside in the physical chassis of that server. Not that common in the data center today, but will be going forward. It's not exclusively required in the servers for all scenarios, and I'll touch on that shortly, but it's there as part of that going forward look. Virtual Machine Manager will be heavily involved in provisioning shielded virtual machines and also managing the legitimate hosts or the host infrastructure.
In VMM, it's a couple of checkboxes to make sure that, to deploy some of this infrastructure. It's not, there's pieces you have to put out there, but the actual administration and setup once all the core bits are in place is not that complex with the VMM.
No, the setup of the host guardian service and some of the attestation components and so on is a little bit more complex, and we've documented it for TP2, and I'm sure we'll do that for the next preview. But ultimately, once you get into the point where you're at the tenants consuming this, it's actually relatively straightforward. And then you'll see we've got this host guardian service, which is providing that host verification. Is this host legitimate? How do we manage the VTPM, the virtual TPM chips that exist in the virtual machine, the decryption, the encryption, and so on. So there's lots of moving parts. And those shielded VMs, we don't require a physical TPM to create the virtual TPM. We're doing it in software, but they can only run on fabrics that are designated as owners and are legitimate hosts. And you can convert an existing running VM to one that is shielded. So there's a bit of flexibility there around how you utilize shielded VMs. But ultimately, what's the assurance goal? Well, we want to enable the use of disk encryption within the VM, so things like BitLocker. For compliancy, that's fantastic. It checks a box for a lot of organizations who traditionally haven't been able to do that. When you live migrate the VMs, that's fine. The traffic is encrypted as well. So live migration and VM state encrypted. And the host admin can't access guest secrets, can't access and can't run arbitrary kernel mode code. So we're really protecting that virtual machine through that separation layer that we talked about. And the workloads can only run on legitimate hosts. So those healthy hosts that have been proven to be legit by the host guardian. And you'll see that there are two types of deployment options. There's one on the left where we're using hardware encryption So TPMs inside the Hyper-V host, and this needs to be a TPM 2.0 with UEFI BIOS 2.3.1. So this isn't as common in the data center. It is a little bit more complex to set up, but it allows the highest levels of assurance to ensure that those Hyper-V hosts are legitimate, they're compliant with code integrity policies, as integrated with the host guardian service. However, most of you want to test this out, you'll be doing it with admin trusted deployments, so using and integrating with Active Directory. So you set up trust between the host guardian service domain and your regular administrative domain, and you go from there to be able to deploy the shielded VMs.
Interesting comment there, between the host guardian service domain and the shielded VM domain. So what's the rationale behind that?
So you mentioned earlier that there was a separate forest, separate domain. The key thing is if you use the same domain, if you're the Fabric admin and you use the same domain for the host guardian service, what are you actually saving? What are you actually gaining? You're still the administrator of the environment. So by having this idea of this trusted administrator that is in a separate environment, that is trusted by the tenant, so like the customer who's running on your infrastructure, that provides them with the knowledge that they are running the shielded VM on a trusted platform, and they have the keys to. So
like the thing I guess that's key to remember is that domains are not security boundaries. That with the introduction of forests and multi-domain environments, the forest became the security boundary. And so what this architecture does is take those most critical components and put them in a separate forest that has a one-way external trust, right? And what that does is keep those decryption keys for the VMs in a place where even the Fabric administrators of the production domain don't necessarily have access to. Domains are not security boundaries when they're within the same forest. Domains are only security boundaries if they're in separate forests, which effectively makes the forest the security boundary. So that's, you'll see this in the documentation. You'll sit there and go, well, why do they want another forest for this? I mean, it doesn't have to be a big elaborate forest. It can be, it could be as little as a single VM, single domain, single machine forest. But the idea is to establish that security boundary.
So let's take a look at a demo. Enough speaking from me. Let's check it out and see what the end result is from a system that's been shielded.
So what we've got here, if you want to have a look down on the screen for me, is this is just a simple Hyper-V host setup, and I've got a VM running. And what I've done is through the hardware settings, and I've already booted all this just to save it a little bit of time, is we've got a few new options, and one of them is for a Gen 2 VM, this security node. And this security node lets me enable two things: secure boot, which we're going to talk about in a little bit, I think, correct? And also enable TPM. Right? So I've enabled the TPM and I've booted the VM. And so by enabling the TPM, what that does is expose within the virtual machine itself. I'm just going to come in here and go to Device Manager, which is this guy right here. I've now got a TPM module. And this is a software-based TPM module.
This is in the VM that we're
in the actual virtual machine.
Right.
Okay. Now, because I have a software-based TPM module, that lets me BitLocker the drives. Okay. So there's two kind of steps to this. One of them is turning on the TPM within the VM and having the fabric for the distribution of the TPM keys. Once that's there, it's ultimately up to the administrator of the virtual machine that's running to choose to now BitLocker things. And so once they've BitLockered things, now this VHD and all the contents of the VHD are protected. And it's using the exact same industry standard encryption and that BitLocker uses. And the current thinking in the industry right now is that BitLocker is secure. So it's leveraging that existing BitLocker technology, and you're not doing anything special at this point. You've put a TPM in the VM, you can now BitLocker the drive. So what I'm going to do is come out here and actually...
Before you go, if you look at the TPM administration at the bottom there, or you can open a fresh one, what does it say for the TPM? Oh, there you go. So manufacturer Microsoft, manufacturer version. That may change, obviously, as we go forward to the final release, but this is a Microsoft-generated
software-based TPM. So we're going to go ahead and actually shut down that VM and just try and take a look at it. So we'll shut that guy down. Now here's, typically when you have a VM, you can offline mount these VHDs. So I'm going to go over here and grab...
That one is actually a domain controller, DCGS there.
So we're going to go grab that guy. So here's the... So here's a VM. We can just double click it.
So that's one that's not shielded.
Not shielded. You can see it just mounts the VHD, and we now, I can go grab the Active Directory database and run home and play with it. I'm the Fabric administrator. If we take that VM that we just shut down, vTPM, that has the TPM in it, and we take a look at what that drive looks like.
I buried it quite deep, just so you...
Double click on it. It's not going to be able to mount this drive.
Boo.
The reason is it's BitLocker encrypted. So now I'm the fabric administrator and I'm the bad guy. I grab this VHD, I take it home. I can't do a darn thing with it.
No, and even if you open disk management on the host machine in this case, and you'll see.
This takes a second to get it.
On this 64 terabyte laptop I've got.
So there it is right there.
Yep. So you can't do a great deal with it.
Right. And again, in order to crack into this, you've got to crack BitLocker. Right. So, if someone cracks BitLocker, there's obviously a much bigger issue, but that's what this is based on. So it's TPM to BitLocker encrypt everything. And then you think, well, BitLocker is specific to this machine. How do we deal with live migration and cluster migration? That's where the shielded VM infrastructure comes in, and this idea of distributing keys to trusted hosts, so that if we move this, the BitLocker key can go with it to the host that trusts.
Or the relevant information, certificates, whatever it may
Correct.
be. Yeah, that's it. So what we just showed you there is just very much one part of the end part, if you will, of it being a shielded virtual machine, and what it brings is that benefit of being able to encrypt the workload, the data, and makes that protected against malicious attack. But obviously there's more moving parts to that overall infrastructure with the host guardian service and so on. But back to the slides, I want to quickly talk through some of the other security features, one of which being secure boot. And it was something that Corey touched on briefly when he opened the virtual machine settings there. And secure boot has been a part of Windows virtual machines or Hyper-V VMs running Windows from 2012 R2 in Gen 2. And introduced this ability, and secure boot in the physical world is all about providing kernel code integrity. So ensuring that rootkits, malware, whatever it may be in the boot process before the operating system starts. And we've now ported that capability into Linux, or into Linux virtual machines specifically on Hyper-V. So if you're running Ubuntu 14.04 or later, SUSE Linux Enterprise Server 12, or going forward, you'll be able to enable, using that PowerShell command that's on the slide, enable secure boot for that Linux-based virtual workload. Now, so again, enhancing security.
One note, on the slide, just a misconception point for people when they first see it. If you just pop the slide for a second, set VM for Ubuntu is actually the name of the VM in there. It's not the name of the operating system.
No, not generic. No.
And so the actual thing that's applying the Linux boot security is the UEFI certificate authority entry.
And have you got a view of that?
I do. If you want to just jump on my screen here real quick. So here's the secure boot option where I enable the TPM. The template is either Windows or consider this second one Linux for the supported versions of Linux, and that may say Linux in the future. I don't know, but right now it's the certificate entry is how you do secure boot for Linux, and so people now know if the Linux boot sequence was good or not, and be able to block the VM. Okay,
cool. So another area of security and specifically isolation is this idea of host resource protection, and this is something that has been pioneered in Azure. Remember, I talked about the consistency before and bringing things from Azure to on-premises. If there are virtual machines that are running in Azure, and we identify through patterns of activity, whether that's certain CPU patterns, storage requests, network activity.
Are you implying people try to hack Azure?
I'm not saying they hack Azure. No, that's not.
They're trying to hack Azure.
Potentially, yeah, they could be.
I can't believe someone would try to do that. It just it seems like
some nasty people out there. But what we've got are virtual machines that exhibit patterns in their usage or activity that don't occur if you've got non-malicious virtual machines. So by able to identify that, or by being able to identify that, we can reduce their resource allocation so that they're not consuming vast amounts of resources to do their malicious jobs effectively, or non-effectively, I suppose. And we can bring that on premises.
Effective malicious code.
Effective malicious code. Nothing like good, efficient malicious code. We can bring that capability, or we have brought that capability on premises in Hyper-V. Now, it's not something you necessarily have to configure. It's just there. It's there in the background. But it's there, and it's another example of bringing stuff from Azure into your data center. So onto availability, and I know it's an area that Corey is very passionate about, and that's clustering. I'm going to blast through some of these clustering slides, because I want to make sure that we've got a bit of time for a break in the not too distant future. But when it comes to clustering is our way in the platform to connect physical servers, or obviously guests as well, but we'll focus on physical for now, with some form of shared storage typically, so that if we lost a physical node, the workloads running on there will restart somewhere else in that cluster. Good example is a virtual machine running on node 1. Node 1 goes away. Virtual machine fails over onto another node automatically. So that's essentially high availability for that workload. But there are scenarios in the current day Windows Server where, for instance, if you've got transient network failures that just occur every now and again, the host gets disconnected from the cluster, maybe drops out of active cluster membership as a result. Those virtual workloads are failed over disruptively onto another node in the cluster. Now, in the next release in Windows Server 2016, we're building in capability that gives you more flexibility around providing that level of uptime for the virtual workload should a node become isolated from the cluster.
The end scenario for this is there's lots of times in production networks where something burps. Is the expression we always use. It's like
nice.
the network's gone, the network's back. What the heck was that? And that can be disruptive enough to cause a chain reaction to really bad things to happen.
Yeah.
There's lots of scenarios where the management tools, the management software can have an issue, but the workload can remain healthy. And what we don't want is an issue in the management infrastructure to take down a workload when the workload was just fine. And so a lot of these features are designed to, hey, clustering failed or storage failed or a connection failed, but let's leave the VM alone. Because if all this stuff comes back, it's going to be fine. But let's not start jumping the gun and trying to panic and get it out of there, only to cause more problems than if we had just left it and let it pause or let it just wait a second.
Yeah.
So it's injecting patience into infrastructure.
Nice.
That's how I think about it.
We could trademark that quote. So that's compute resiliency, but also storage. What if you lost connectivity from a host to its backend storage? Well, in this case, in 2016, we're preserving that tenant VM session state. So the VM it will run as long as it can, and then it will enter what's known as a paused critical state, where the virtual machine stack is said, okay, I can't connect to my hard disk any longer, my virtual hard disk that's stored somewhere else on the infrastructure. It's quickly, intelligently notified of the failure of the underlying, or the connection to the underlying block or file-based storage. And I think you've got a demo of that, is that right?
I'm working on one right here.
It's working on one, okay. Need any more time?
No, we can go ahead. You can jump.
Well, I've got one more slide.
Okay, go for it.
Just to go before we go to your... So the final one is node quarantine. So for instance, if you do have a situation where you've got a node that continually is dropping out of cluster membership because it's just unhealthy, the transient failures are really affecting it, the node becomes quarantined if it unexpectedly leaves the cluster 3 times within an hour. And once that node is placed in quarantine, VMs are live migrated. And that's a key difference there versus the disruptive failure we talked about before. Live migrated from the cluster node without downtime. So that node quarantine is a very useful feature in case we're having just some transient issues that cause the cluster node to leave cluster membership back, leave back, 3 times in an hour, and we'll live migrate those virtual machines back. We're good to go on there?
Yeah, we'll take a look at something right here.
Okay.
Now. All right, so essentially what I've got here, just kind of take a quick look at and show you how some of this works. I've got a virtual machine that's running using some shared storage. We'll take a quick look at the settings right here. And so this guy's using a scale-out file server, and the VM and the VHD and all the workloads all running on that scale-out file server. And so what we're going to do is basically introduce a network failure to the storage. Okay, so this is the storage burps for a second. Now in the traditional world, this would cause a catastrophic failure in the VM. In Windows Server 2012 R2, they've introduced this notion that it'll pause storage for like a couple of seconds, and if it comes back, it'll resume storage. What Windows Server 2016 does is extend that to another level of tolerance, another level of patience. So we're going to go ahead and kind of kill the storage here, just disconnect the network connection that everything is going over. And I think I did this on the wrong host. And what you'll see is the VM enters this running critical state. Okay.
Nasty.
Now, what it's saying is, hey, I'm still running, but there's a problem. I can't connect to something. Okay, and over time, and I forget the exact time, I think it's like 40 or 50 seconds, it'll go from running critical to paused critical. But the VM stays in this kind of running state, and the minute the storage comes back, it will resume again.
But when the VM is paused, it's no longer accessible. It's just
right.
It's just
so we're going to re-enable that storage, and what you should see here is within a fairly short period of time, this will switch from running critical back to just a normal running state.
Right.
Now, we're not going to wait for that because that takes it. No, there it is. That was actually.
You weren't going to wait for it.
I wasn't. It normally takes a little longer than that. But this is one of these notions of just resilient storage, so that instead of immediately saying, okay, storage has failed, let's start taking some action.
The VM and...
Let's just wait a little bit. Yeah. Right. Now, in Server 2012 R2, you wouldn't see this running critical state happen. What you'd see is just kind of pause, and it'll just resume if everything came back in a short period of time. Now Hyper-V is able to detect that and is able to adjust the state of the VM accordingly so that you know it happened, there's logs that show it happened, and if you want to, you can take action, but you can see what the actual issue is. So,
right.
With this one, you can actually see the text on it. Can't connect to this particular thing can't connect to the configuration storage because the configuration of the VM is also over on that shared file server.
Okay, so that's a little bit about that new clustering capability and the redundancy that's being improved within the stack. But when we think about clustering, we don't just think about host clustering. We also think about that next level up of creating clusters of virtual machines. So maybe you want to virtualize a SQL Server cluster, a failover cluster, or another form, just a basic Windows Server cluster, and you need to present some shared storage for that virtual cluster to operate correctly. And that's where guest clusters come in. And this was really enhanced in terms of the way we deploy and manage guest clusters when we introduced 2012 and 2012 R2, with this concept of this shared virtual hard disk, or VHDX, which removes the need, as Corey was saying earlier, to present the physical underlying fabric storage, like exposing your iSCSI, your SMB, or your fiber channel storage through to the guest, because you're essentially punching a hole through that separation layer from fabric to virtual. And instead, you just create shared virtual hard disks that reside on the physical storage, but they're just presented through to the guest. And they provide a lot more flexibility, they're fully supported in production, and some new features. So firstly, online resize. So if I've got a shared virtual hard disk that's exposed to one or two or multiple virtual machines, I can resize that on the fly now with no downtime, which is very flexible. But also, the virtual machine itself sees that SAS disk, it sees SCSI persistent reservation, so it understands what it needs in terms of that building a cluster, building the clustered environment. These shared virtual hard disks can reside on cluster shared volumes, on block storage, so iSCSI or fiber for your physical storage, or on an SMB file share, so they do need to be on some kind of redundant file or storage, file-based or block-based. But the other new thing, the other new capabilities around shared VHDX specifically is that it supports Hyper-V replica, which if you're not familiar with that, I'll go through that in a minute, but also host-level backup. So these were key things that were missing in the current release.
It's now become a
2012 R2.
First-class disk citizen.
Yes, a first-class disk citizen.
Exactly. I mean, prior release, you could create a disk and you would flag it as shared VHD. Now, if you look at the screen here real quick, there's actually a type of VHD that you can define. Over on just on my screen for a second, please. Over on there's a new type of hard drive you can define called a shared drive.
Yep.
And that creates a VHDS file, which is a first class. It's a VHDX file, but it's known to be shared. Everything understands it's shared, understands more than one VM actually uses this, and the backup software, the replication software, everything plays nicely with it now.
Yep. So
you no longer just create a normal VHD and flag it as shared, you create an explicit shared VHD.
Yep, and the administrative experience, as you can see, is more streamlined as a result. So.
Exactly so.
So that's just a little bit about shared VHDX, but I mentioned before that Hyper-V Replica now supports it. And if you're not familiar with Hyper-V Replica, this is a software-based VM replication technology that is built in to Windows Server today, and obviously going forward as well, that enables me to replicate virtual machines and their disks at frequencies of every 30 seconds, 5 minutes or 15 minutes across the network, across sites, into Azure with integration with Azure Site Recovery. And the beauty of this is it's very simple, very efficient, and enables me to fail over in the event of a disaster. So for instance, if my primary site, after the replication has taken place, gets hit, I can bring those workloads up on the secondary site. And it's just replicating the delta changes each time. So it's not replicating full copies of the virtual disk. Once that initial replication is done, we're just doing the changes. And now with shared VHDX supporting replica as well, and if we look on this next slide, you'll see, so when you add a new virtual hard disk to a VM that's currently being replicated, it's automatically added to the not replicated set. So in the UI of Hyper-V Manager, you'll see a new area that shows you which virtual disks are currently being replicated for a VM, and this will fall into the not replicated set. Online, while the VM is running, you can set this, for this particular virtual machine, add this extra hard drive, and obviously start replicating.
I can take a quick look at that here.
Have you got it?
I do. So have a look down here. We have, I say down because you guys are probably looking up at your screen. Mine's down here. So I've got a VM that's actually set for replication. This is already set up for replication. I can't boot this as an empty VHD, guys. I wanted to replicate really fast.
Yeah.
So this is already set for replication. You can actually look at the the replication status that's over here. And you can see, let me just maximize some of these windows, and you can see it's set to replicate. It's replicating to VM host 2. And we can actually take a look at the settings on it, and you can see which disks are included in the replication set. There's the replication, and we can see which disks are actually part of that. And so the thing is, we want to make sure that any new VHDs we add get included with the replication set. So that's now possible. Prior, you'd have to remove replication and add it again.
Yep.
So it's pretty simple to do. We're just going to add a new VHD to this running VM.
So this is asynchronous replication as well, isn't it, with Hyper-V Replica? So I was just asking on the question.
Yep, this is just using standard Hyper-V Replica.
Yep.
So add a new hard drive. I'm just going to do a new VHD. Just going to make a nice little empty VHD here, dynamically expanding. We'll call it Replicate 2, Rep 2. And so that VHD now, Rep 2, is now actually added to the VM. However, it's not actually being replicated. So what we're going to do now is go ahead and actually configure replica on that.
You could add it through the UI, I guess, couldn't you, I suppose?
You can't actually. You got to do it through PowerShell.
Oh, right. There you go.
So clear up some of this stuff here. I grab my PowerShell command for this. So I'm going to make this a bit bigger. There we go. So we're just going to set our VM replication. And I have a VM called Replicate Me. I'm used to the keyboard on the laptop, not the keyboard up here.
A bad workman always blames his tools.
It is. So here's the disks that are replicated. So basically, we have a VM that's got a set of replicated disks, and we're simply going to add all the hard drives that are there. Now, this command's going to not add 2 of the hard drives and just add 1 of them, but this is kind of the, I guess, the cheap and simple way to do it. So we'll go ahead and run this command. And now we go back and look at the properties of that VM again. And look at the replication set, you can see that we've now got an additional VHD. And right in the background here, happened really quick, but you actually would see the status go replicating. You did catch it there?
I did see it, yeah.
So actually, let's quickly replicate because it's going to now sync up and add that new drive. So what we've done is, expanded the storage, added to the replica set, and it's now fully replicated.
Very straightforward, very ezy.
So it's a new thing you couldn't do before.
Yep. So that's a bit about replica. Moving on to memory management, something I suffer from, memory management. I didn't even know I had to be here today. So when we think about memory, there's a couple of different ways you can manage Hyper-V memory. Firstly, static. Easy stuff. You just configure what's known as the startup memory. That's the amount of memory that Hyper-V will give to the VM no matter what, whether it needs 1 gig, whether it needs 10 gig. If you give it 6 gig, it's just got 6 gig, that's it. However, there's new capability with dynamic memory to give you more flexibility. You enter the startup, what you want the VM to start up with, the minimum, what it can drop down to if it's quiet, the maximum, what it can grow to if it's busy, but you can now increase or decrease VM memory without VM downtime. So you couldn't do that prior to 2016. So you can adjust some, I think you could adjust the maximum, but you couldn't decrease the VM memory without VM downtime. And it can't be decreased lower than the current demand, obviously, or increased higher than what you've got in the physical system. So it's just giving you extra flexibility. It gives you more freedom when you're deploying virtual machines to be more flexible about the settings you give for each particular virtual machine. So have we got a quick look at that one?
Yeah, you can have a look over here. So I've got a bunch of VMs over here that are running. A couple of them are Nano server VMs. We'll be playing with Nano tomorrow, but Nanos, I love me some Nano. So we're going to look at these Nano VMs, and I've got a bunch of Nano VMs here. And you can see by looking at, they got basically 4 gigs of RAM. So what we're going to do is we're going to set that higher.
Are these currently configured with dynamic memory or static?
Well, so these are currently configured static.
Okay.
Okay. And we're going to take this to, I don't know, let's go to 8 gigs. And watch them. You know what? I may have just exhausted my memory on this box.
I know, one's gone. One's doing it.
Yeah. There's 64 gigs on this box, and I'm about to go 7 VMs at 8 gigs. Fingers crossed.
Indeed. It could be catastrophic.
Well, I'm used to boxes with, honestly, with 512 gig of memory. That's what I'm used to working on. So you can see what happened. We just bumped them up. And now we can just go, that's kind of cool and dandy. And again, these, to prove the point, these are actually static set VMs. This is not dynamic memory by no stretch of the imagination. This is full-on static memory. And we'll take them back down to 4. And so what you're seeing here is a rather interesting point. It's not going to drop it if it can't.
Yes.
Right?
So
I've pumped these up. It's consumed. You can see that one of them actually dropped it. Okay. Try that again and see.
Yeah, one's dropped.
So they're starting to drop some of them.
Yeah. You can see them on the right.
Yep.
Cool.
And
so you've got flexibility now you've got dynamic memory where you can start to, the system will automatically adjust the memory higher, lower, and you can adjust that at runtime while the VM is running. But what you're showing there is also the ability to do that with static memory without any downtime.
It's not letting Nano 2 go back down, which is fine for whatever reason. But we're not going to worry too much about that. No. We'll try and take them to 6.
So that's a bit about memory management. But what about networking?
I'm just playing with this now.
Carry on, yeah. So networking, we've got a dedicated module for networking later today, but just with the VM networking adapters, there's some improvements around the flexibility for administrators, around not only being able to hot add virtual network adapters to the VMs, and again, this is enabled by default, but it's for Generation 2 virtual machines only. So you can add virtual NICs to a running VM using Hyper-V Manager or PowerShell. Obviously, you'll be able to do it with Virtual Machine Manager going forward as well. But also, there's some new capability around VNIC identification. So for instance, when you create a new network adapter for a virtual machine, you can say, I would like the virtual machine's network adapter inside the VM to reflect this particular name. So you've got some flexibility there.
That is, like, that right there is just one of those godsend things. Because how often have you sat there and gone, I've got 4 virtual NICs and I've got 4, which one is
Ethernet 1, Ethernet 2.
Is Ethernet 2 connected to Intel 360A? And now it's just the names are consistent.
Can we see any of them?
I can't show you the names, no, because it's not working properly.
Right, okay.
But what I can show you is the hot add real quick. This is a piece of cake. I love this one. So I've got a network adapter, but I want more network adapters. So we can just add network adapters. We'll just add some network adapters. I'm not even going to connect them to switches. We're going to add some network adapters and go, hey, network adapters, and all of a sudden we have network adapters.
Boom, boom, boom.
And we go, why? Why do I want that many network adapters? But because I want network adapters, but that's not possible because I don't need that many, so let's just get rid of some network adapters. So we go, I'm just on a network adapter binge, adding and removing. So we remove some network adapters, and the network adapters go away.
It may disrupt traffic if you remove
if you remove the NIC, it may, exactly. So
it's always good to know.
Yeah, but yeah, that like hot add, hot remove network adapters. Again, it's one of those things where, there's 2 things right there. We talked about, mentioned very early in the beginning, like eliminate reboots, eliminate downtime. There's 2 things right there. Switch static memory, because remember, dynamic memory,
not right for every workload.
It's not right for every workload. However, you may discover that your static value was too low or too high. Now you've got to reboot to fix it. Now you don't have to reboot to fix it. Now you can just go fix it. And the same thing with networking. All of a sudden there's an issue and you want to go from single adapter to teamed adapter, but you only got 1 NIC. Now you can have 2 NICs. So again, it's reboots are the death of converged infrastructure.
Yeah.
Reboots are the death of cloud services. So get rid of reboots. And these are 2 things right there. That's 2 reboots you no longer have to do.
Yep. Cool. All right.
So somebody do this.
So where an area of reboots is required is with upgrades. I don't think we could escape upgrading the OS without a reboot, but you never know, maybe in the future. But what I want to talk about now is how you can start to move from one release to another in a streamlined, automated, efficient fashion without downtime to the workloads. So yes, Fabric, obviously there may be reboots there, but the workloads that you're running in the virtual machines on top of the Fabric, that can stay up and running. And what I want to focus on is this cluster OS rolling upgrades, where you can upgrade the physical cluster nodes. I suppose if you were using a guest cluster, you could use the same, without downtime to the key workloads. So you can upgrade the OS of the cluster nodes from 2012 R2 current to the next release, so Windows Server Technical Preview. You'll be able to try this out on TP2. You can do it over TP3 very shortly, without stopping the Hyper-V fabric, or if this is a scale-out file server you want to upgrade, the file server nodes themselves don't have to be, the file server workload wouldn't need to be taken down. So it means you can keep pace with innovation in the industry and in Windows Server specifically without impacting your running workloads. So what's the process? Well, it's a phased approach. We get everything off that particular node we want to upgrade, and I'm showing you the very manual approach here. I'll talk a bit about more of an updated and more of a streamlined automated process very shortly. But we've shifted all the workloads, whether they're virtual machines, whether they're scale-out file server nodes, off one particular node. And then we're going to upgrade, or we're going to evict that node from the cluster first, replace it with a Windows Server next release, so let's call it Windows Server 2016. We add that node back into the cluster, and then we move workloads over to it. So we've got a mixed mode cluster where we're running 2012 R2 and 2016 on the same, in the same cluster. And you'll see the animation is showing us, okay, we're doing the same again, we're live migrating virtual machines. Once the cluster is fully upgraded from a node perspective to 2016, we can then, it's still running at a 2012 functional level. So we can update that very, very easily, and using this PowerShell command, take advantage of the new features in 2016. Over to you, Corey. Give us a demo of cluster upgrade.
All right. So what I've got here is a very simple failover cluster. Now, this also answers, we keep an eye on the chat window. One of the questions that came up was, do I need VMM to do clusters? No, you don't. Clustering is built in. VMM just manages many clusters across many different environments. So VMM is big, broad scale management. All the clustering technology is part of Windows Server. This is the obviously built-in Windows Cluster Manager. And what I've got is a 2-node cluster consisting of Windows Server 2012 R2 nodes. And now this is a full disclaimer. I'm doing this to be quick and efficient. This is a file server cluster. If this were a Hyper-V cluster, everything I do would be identical, okay? With the exception that the migration of the role would take a few minutes longer because it's migrating a VM as opposed to migrating a file server object, which takes a few seconds. But what I'm going to do, so here we got 2 nodes. I have 2 additional nodes. I've got FC node 1 and I've got FC node 2. And what I've done is connected those nodes to the exact same storage. So I'm using iSCSI for simplicity, and I have a Windows Server 2012 R2, 2 nodes connected to an iSCSI SAN. I've now plugged 2 2016 nodes into that exact same iSCSI SAN. And what I'm going to do is just simply add those 2 nodes to my cluster. So here under nodes, and I'm going to add node. I'm going to add in 2 additional nodes. FC node 1 and FC node 2. And so it takes just a second to reach out, connect to them, make sure that they are in fact have the cluster roles installed. If it's not, it will actually install them, verify they've got the right IP connectivity, verify they're all good and healthy. And so just give this a couple of seconds to go through, and they're good. We hit next. We're not going to run all the cluster validation. Cluster validation is fantastic for setting up clusters. It tells you exactly what's configured correctly, what's not configured correctly. I know this is good, so we're going to skip the validation. It also takes a few minutes.
This MMC is 2016, right?
Yes, it is. This is 2016 MMC. Click next, and it's going to now add those 2 nodes to the cluster. Because the storage is already connected, there's nothing I have to do other than just add the 2 nodes. Now, the storage, we'll go through the process of doing the storage connectivity. That's, it's a little bit out of scope for this demo, but I just merely connected the iSCSI storage. And this takes maybe 15, 20 seconds to go through.
I think the key point here is that you're adding 2 cluster nodes that are 2016.
Yes, so now I now have a mixed cluster,
right.
Mixed operating system cluster. And this is the new thing, okay? You could not have this in 2012 R2. You could not have a fully functional cluster where you have nodes running different operating systems. Again, full disclaimer, this version of technical previews is TP2.
Yep.
So you can actually do this on the existing one today. I didn't upgrade this particular demo, given that we only got the TP3 bits, because most of what we're doing here is on TP3. We only got those a couple of days ago. So we did. Yes, so there wasn't time to upgrade every single little tiny thing. But the process hasn't changed. So now I have a fully mixed mode cluster. And so all I've got to do is take this role and go say, you know what, you're on 2012 R2 right now. Let's move you to one of the known technical preview nodes. And it's done. Now this would be no different if we're VM mid live migrated.
Yep.
Now, important point on the live migration, which deals with what we call VM configuration versions. More on that in just a second. So now all I need to do is take my other 2 nodes, node 1 and node 2, and just evict them.
Sounds a little bit harsh.
Well, they didn't pay their rent.
No. But that's, I mean, you've got the luxury of having 2 spare hardware nodes there. But if you had 4 nodes of Hyper-V today, 2012 R2 in use, you would have to do what I did on the graphic, is move the virtual workloads onto fewer nodes, maybe 3 out of the 4, evict one, upgrade it, add it back into the cluster, and then move the workloads over and go through.
And so what I could do now is take 1 and 2, OS upgrade, add them back in.
Add them back in, yeah.
And now I've fully upgraded. Now there's one final step you've got to take, which is once you've now complete, well, first of all, I need to disconnect the old storage. I'm not going to bother with that. But I need to go on to the R2 nodes. If I'm doing a true migration like that, I disconnect the storage, and now I've got gone from an R2 2-node cluster to a 2016 2-node cluster, or upgrade those 2 nodes, bring them back in. Now I've got a 4-node 2016 cluster. But once you've gone to that newer version, in order to take advantage of some of the additional features of a 2016 cluster, you've got to do what's called a functional level upgrade on the cluster. And that's a simple PowerShell command. Upgrade. Update. Cluster functional level. And point it at the cluster, what's my cluster name? Cluster 1. And it'll now do a one-time upgrade. Now at this point,
that is a one-way operation.
One way, one time. Once it's done, and it now no longer supports mixed mode.
Yes.
Okay. So
or at least mixed mode from the previous to 2016.
Correct.
You could have mixed mode going forward, I guess.
Right. You can't have mixed going backwards. Right. So once you upgrade the functional level, it's a one-way trip. You're done. It's like doing a domain functional level upgrade. For you AD admins that may be now playing with this. Yeah. Typo. So the other point to this, it deals with the versioning on the virtual machines, right?
Yes.
So we had with 2012 R2 the ability to do a save state. There was save state compatibility in forward versions. So you could take this, you could live migrate from 2012 to 2012 R2, and that was done to allow you to kind of solve this scenario of how do I get a workload, from one cluster to another cluster. But you would have to build 2 separate clusters, migrate the workloads, and it was a lot of work. This means you don't got to rebuild the cluster. You can literally just take a node down, upgrade it, and move things back and forth. What this is done by is something called the VM configuration version. So as you move a VM from 2012 R2 to 2016, in order for that VM to take full advantage of all the features of 2016, you need to upgrade the configuration of the VM. So things like VTPM, HOTED, VNIC, et cetera, et cetera. And so once those VMs are migrated, after you've upgraded the cluster functional level, you want to go in and update your VM configuration level. So it takes them from the XML-based configuration format to the new bin-based, binary-based configuration format, and now you take advantage of the full set of features on 2016. So I know that didn't take all that long, and it took a little bit to set it up, but it really is that simple. That you now have compatibility between versions of the cluster.
Now you might think, okay, well, that sounds great, but the graphic and what you did was very manual. I did it through Cluster Manager. I already had the other nodes that I wanted to bring in to the old cluster staged and just added them in, and he made it look very easy. But in reality, it's still quite a manual operation. It could be automated through PowerShell. However, if you're thinking about this from a virtual machine perspective and upgrading Hyper-V hosts, if those Hyper-V hosts are managed through System Center Virtual Machine Manager, specifically the 2016 release or the technical preview release, and you're managing a 2012 R2 cluster, so VMM 2016 technical preview managing 2012 R2 cluster. VMM knows everything about that cluster. It knows its configuration, its NIC settings, its storage access, and all that stuff. If you then include within your VMM library a physical computer profile that you would use to bare metal deploy new hosts using VMM, if you've got all of those pieces set up, VMM knows about the 2012 R2 hosts. It knows you want to deploy a 2016 cluster or upgrade that cluster. VMM will automate all of that process for you, and that's new capabilities coming to Virtual Machine Manager in the next wave.
So there was a question here I want to address real quick. Someone said, "I hate PowerShell. Why can't we do this in Server Manager?" Number one, don't hate PowerShell. PowerShell's your friend. PowerShell, honestly, if you want a future in network administration, you got to know PowerShell. It's unavoidable. So learn to love it. Secondly, Server Manager for the stuff you do every day. The one-offs, the things you do once in the course of building and maintaining, will almost always be in PowerShell. Because it's simpler and easier to maintain and deliver them there. So those one-off tasks will always be in PowerShell. Plus, PowerShell makes you look smarter.
There you go. You heard it here first. So
you should try using it.
I've tried. I do learn to love it eventually. That's enough about upgrades. We've got one final section that we want to talk about, the fun stuff, the cool stuff or driving operational efficiencies if we're being very formal. The aim of this mini section of the module is just to help you understand just some of the other periphery stuff that's really cool, really useful, might make your life that little bit easier around Hyper-V. And there's 4 or 5 little things that I want to talk about before we dive into the next module, which will be storage. So, firstly, checkpoints, also known as snapshots.
They're different now.
They are different now. There's a new feature, and it's something you can enable called production checkpoints.
Well, it's enabled by default.
Well, yeah, on by default, you can choose and alter. You can alter this setting if you want from production to standard checkpoints. But production checkpoints are new in this release, and it enables you, or it uses under the covers, VSS inside the virtual machines to create production checkpoints instead of save states. No change to the user experience, no change to the way you take a production checkpoint. But it's really a more efficient, more scalable, more streamlined way of...
Well, and so I'll call it a couple of things on this, because this is one of those little features that will bite you in the butt if you just take it for granted. If you're one of these guys that uses Hyper-V or girls, I'm not discriminating, one of these folks that use Hyper-V and you take checkpoints a lot to preserve your work as you build VMs and whatnot. Maybe you're building out a production system, you want to take the checkpoints. They always contain a save state, so you revert to the save state and you leave things on the desktop and things running. Production checkpoints do not include save state. It's a checkpoint of the VM in a powered off state. Okay, so it is fundamentally different than the standard checkpoint, which is what Hyper-V has used up until this point. So you need to be aware that when you take the checkpoint, you go back and apply it, the VM's not going to be running. It's going to want to boot. Yeah. So if you're
boot cleanly.
Yeah, correctly. It's going to be file system consistent. It won't go, oh, you just pulled the plug.
And app consistent.
So it's it's safe to use in production. So this mantra of checkpoints, don't use them in production, is now we have a production version of it, so use away at it in production.
Yeah. I mean, you'll still want to make sure that the workload you're looking to checkpoint.
So if you have a look down here in the UI real quick, if we look at the settings on this VM, and we click the checkpoints option, this is a per VM setting. You can see that we can enable and disable it, which is new. And then we have production checkpoints. Okay, so we have 2 options. If we can't create a production checkpoint because maybe VSS is not working correctly, maybe the VM doesn't support VSS, default back to standard, or if we uncheck this, it won't let you do a checkpoint. And then what we've had all along, and what everyone's used to using, is this standard checkpoint. So you can adjust the type any way you want. If you're using this for DevOps or building things and playing with things, you probably want to switch this to standard because it's what you're used to. If you're going to use this in production, you obviously want to set it to the production checkpoint value. And otherwise, it works the same way. If I go ahead and take a checkpoint of this VM, mouse behave, and I do checkpoint. So this is going to production checkpoint. So that's going to take the checkpoint, and once that finishes, which won't take all that long, you'll be able to look at that checkpoint down here, and you'll see that it's actually in a powered off state. So there's no thumbnail for that checkpoint because that's a powered off VM. And if I apply that checkpoint, it's going to boot the VM from scratch.
Right.
Okay? But it will be disk consistent. So, little thing, but also a big change in the way that checkpoints operate.
Now, one other capability, if we go back to the slides for a sec, that is, for me, a significant game changer for the way you administer virtual machines, particularly in deployment scenarios when you want to ensure that a virtual machine has the right roles and features installed, or there's something you want to push in to the VM. This is PowerShell Direct, where we're essentially bridging the gap between Hyper-V host and guest VM in a secure way to issue PowerShell commandlets and run scripts inside the VM. So you don't need to configure PS remoting, you don't need the VM to have network connectivity, but from the host into that guest, you can fire PowerShell commands, commandlets, workflows, whatever it may be. And it's as simple as invoke command, VM name, script block, and then insert your script. We've got a...
I do. I remember when I first learned about this, I remember telling my wife. And because I had to tell somebody. And she's just looking at me like, what? You're a nerd, go away.
She said, would that work for shielded VMs? Is that a question back?
No, that's not what she said. I believe it was you forgot to put out the trash.
Right, yeah.
So what I've got here is, PowerShell Direct is the ability to, as you said, run a VM or run a PowerShell command in a VM. That was my watch beeping. Sorry about that.
Yeah. Your heart rate stopped.
No, actually, it's my Garmin watch that told me I had to move.
Yeah,
so I'm not moving enough.
There are other watch manufacturers as well that you can use.
Good Lord.
Yeah.
So at any rate, if you have a VM, here's kind of the big scenario use case for this. If you want to PowerShell manage a VM, you've got to have IP connectivity into the VM. Well, what happens if your administrator disables the adapter, turns off RDP? What if they do something to disrupt network connectivity? What recourse do you have to fix that problem? And the answer is nothing really. You have to now go to the console and interactively log on. And if you're in a hosted environment, a multi-tenant environment, or a mass data center environment, that's probably not going to happen. You can't do it on Azure, for example. If you cut it off, you're in a world of hurt at that point. This gives you the ability to now bypass the network infrastructure, use essentially VM bus to layer PowerShell commands into the VM. And it's literally this simple. Take a look. I've got a VM called workload 1 that's running, and I'm just going to go enter PS session. And this is the new command, VM name, workload 1, workload 1, not 12. Now, you need to have credentials, right? This is not bypass security. I've got to have guest VM credentials. If I don't have guest VM credentials, I'm not going to get in there. So. So we wait. And so here's the guest VM I'm actually connecting to. And we'll show you a couple of quick things once this goes through. So now I'm in. If I go host name, I'm now on the VM called workload 1. When you first go, what you're seeing here is PowerShell being PowerShell and just compiling all the commands and taking just a second. So just be patient with me. It will.
Could be a really long host name.
Well, it could be a really long host name, but you can see it's actually running, trying to compile all the commands over here. Oh, there we go. It just so it kicked me out.
But within that virtual machine, not only could you get the host name or whatever, maybe there you go. Just needed that second time for the login.
Yeah, so it's now we're now logged in there. And so, for example, I can do very simple things like look at the IP address. This is the IP address inside that machine.
Now your VM has a network adapter. Obviously, this would work.
It does. But for example, we can go get have a look at what the net adapters are. Now, one thing to be aware of is that when you do this, you lose the auto sense in PowerShell. So if you're addicted to tab complete, because you don't want to know your PowerShell commands, doesn't work in here. Maybe it'll come in the future, but at the moment it doesn't.
This is something you could use. You could run DSC scripts, desired state. You could deploy roles and features, turn them on, and do a real deep configuration of a VM that you've perhaps just deployed, without even the network connectivity.
So we can do something like. We can turn off the network adapter in the VM. So now I no longer have network connectivity. Right, this is the typical mistake, and I can now go turn on the net adapter in the VM. Network adapter is turned on. I can do things like get process. So here's all the processes running in the VM. And so now you kind of start to see the power of something like this. Get process. Got Notepad, let's kill it.
It's a little bit harsh again, but.
Well, I don't like Notepad on my servers.
No, fair enough.
Hey, look, it's now doing autocomplete. How cool is that?
Is that what you said it doesn't do?
It is. I'm surprised. So, well, it didn't do it in TP2. There you go. So, hey, so Notepad's gone. So again, without the network adapter, right? Well, it's enabled here, but I disabled it. But point being, I'm not using IP connectivity or network connectivity to do any of this.
Correct.
So now you can build VMs, build everything without needing any sort of IP connectivity. And if you're in a multi-tenant, big enterprise cloud environment, this gives you, if you kind of, let your imagination wander for a second, imagine scenarios where you build a tool that allows a customer to submit a PowerShell command to be run in their VM outside of the network stack. right? So here's my, troubleshooting PowerShell command. I can't connect to my workload, run this thing in the VM that makes sure the adapters are enabled, make sure the IP is set, returns, finds out what the IP address is, all sorts of fun stuff. There's like the possibilities here are endless.
Yeah, there's a lot of opportunity there. So final one. So Hyper-V Manager, Corey was using it before to take the snapshot, take the checkpoints more specifically. But Hyper-V Manager has also had a bit of an overhaul, not from a GUI perspective and how it looks and feels.
It looks the same.
It looks the same, but you can connect to Hyper-V servers using alternative credentials, using IP address, so a lot more flexibility for the administrator if you are managing multiple hosts in different environments.
Yeah,
and you just want to
I frankly don't recall the details, but the underlying protocol's changed as well. So it's now using WMI WinRM as opposed to whatever it was using before, which wasn't WMI WinRM. And so we can now just go connect to a new host, and you've got this very simple, very subtle new button, which is connect as.
Yeah.
Right.
You have to specify a computer first, and then.
Well, clearly.
Yeah. I'm just saying.
Way to go, Mr. Robbins. So you connect as another user, right? So we can now do alternate credentials, which I know has been a big pain point for a lot of folks. So.
Yeah. And the final one, and it does lead us into the next module quite nicely on storage, is this idea of using REFS, a resilient file system, as the backend for your virtual hard disks. Now, many of you, when you deploy a new volume for storing your virtual hard disk and running your virtual hard disk, chances are you'll probably just go NTFS, you'll choose your cluster size, you'll choose whatever it may be, or you'd just accept the defaults, go, go, go. Whereas now, REFS should be, going forward, your default choice for volumes that will host and hold virtual hard disks for Hyper-V. Maximizes data availability, very resilient file system, as the name would suggest. But what it enables for a Hyper-V VM and for you as the administrator is rapid fixed disk creation. And we mean rapid, and we'll show you a demo very shortly. And if you are merging in those checkpoints, if you've decided I'm going to clean up all my checkpoints and merge them back in to the main virtual disk, that's accelerated as well. So those kind of operations that can, especially fixed disks, they can take a long time. This is going to help. So what have you got? So
take a look here real quick, and this is very kind of anticlimactic to a degree, but I've got a volume. All these VMs that you're seeing on this are running on REFS volume. So REFS is your new default volume that you want to use for Hyper-V VHD storage. And so all I'm going to do is just kind of illustrate the point of this here. This was something in the past you needed ODX to achieve, which is very particular hardware, typically fairly high-end hardware. So we're just going to do a new VHD. So new hard disk, and we're going to do two little examples of a fixed disk. So we're going to do a VHDX. It's going to be a fixed size, and so if you've ever done this, this potentially takes a long time. So we're going to call this one FD1, and we're just going to throw it on the C drive. Make a little folder called VM Store in the C drive. And we're just going to throw a disk in there. So this is a fixed disk, and we're going to make this one not 127 gigs because we'll be here till tomorrow.
Okay.
We're going to make this 1 gig.
And this is on NTFS.
On NTFS, and we'll just hit finish. And you can see that this is going to take not a lot of time, but a little bit, right? So a couple of seconds. We're going to take that exact same process.
That was quite fast, actually.
It was. I maybe need to do a bigger one. Let's do a bigger one so we can make it take a bit longer.
I was going to say, people wouldn't be too worried if that was.
Yeah, I know.
Although a 1 gig fixed virtual disk isn't.
Do a little bit bigger. Let's do 10. Now, if we wind up sitting here waiting for 5 minutes, Matt, this is going to be ultimately your fault.
Well, the other one finished so quickly.
I know.
That's more like it.
There we go. So let's do a little bit longer.
Yeah, see?
So while we're waiting for this progress bar, Matt's going to tell us something interesting. Because this was his idea.
Well, I mean, you were very agile moving around the UI there. And anybody who's created fixed size virtual disks, if you created a 64 terabyte virtual disk, which is the biggest, that would take a long, long time on NTFS, especially if you don't have any hardware offloading capabilities.
The other trick, by the way, is rotate the screen so gravity helps the progress bar.
Is that right? Yes. Right.
Gravity assisted.
Excellent.
Whatever. So now we're going to do the exact same thing. We'll do 10 gigs as well on REFS.
So how long did that take? I mean, my maths isn't great, but I think that was about 40 minutes.
Again, you're in America. It's not metric.
Sorry. Fixed.
So fixed size, yes.
Yep. Confused. I don't when you're cheating.
Good Lord. So let's do FD3.
Yep.
And this is on D drive. D drive is REFS, which I'll prove by going over here and doing the old file system properties on it.
That old one.
And so you can see it's actually formatted REFS.
REFS, okay.
And so we'll go back over here, Hyper-V Manager. So this is on REFS, and we'll do this one as, well, let's just go.
Let's hope this isn't.
Go 50 gig.
50 gig. So it's not an apples to apples test now.
No, it's an apples to a bag of apples test.
An apples to a tree.
Exactly, and we're done.
No, hang on. I looked at you then and it had finished.
It's done. It's literally that quick. And we can actually go find that disk over here. And this is a fixed size disk on D. There it is right there.
You know, and that's a fixed size virtual.
Fixed size.
That is rapid.
It is.
Nice.
Now, there's a few other things that are really, really cool about this that are a little harder to demo.
Right.
Take a lot more time. One of them is merges on snapshots. So if you've ever taken a VM, you want to export and merge all the snapshots, or even just delete a bunch of snapshots or checkpoints, the merge takes time, especially if this has been running for a long time. I've had VMs in the past. It's a 4-hour operation. If you do this with VHDX on RFS, it is instantaneous because it doesn't copy bits, it updates references. That's the really non-technical loose description of what happens. So it doesn't actually copy bits, it just updates all the references to everything. So when you go, take this, let's say you take a snapshot of VM and you install an operating system, then you delete the snapshot, it's got to merge 8 gigs down. With REFS, it goes done.
Right.
It's literally that fast. So merging of snapshots is instantaneous. I've snapped my fingers now 5 times.
Yeah, nice. So your watch will be beeping again.
It will.
Your blood pressure will be rising. So that's a bit about REFS, incredibly powerful technology. And like I say, if you're going to embrace Windows Server 2016, don't just go for your default NTFS, next, finish. Really think about embracing REFS for that back end, because I think certainly creating fixed virtual disks and deploying and merging in, as Corey said, is going to be significantly improved. And that concludes our virtualization module, and we're going to now plow on into storage.
So before we do,
that was a nice segue there.
Well, it was. There's a couple of questions that have come up pretty regularly on the Q&A. I just want to call out. One of them is Gen 1 versus Gen 2 seems to be over and over and over and over again.
Were you a doctor in a previous life?
No, I just never actually learned to write.
Oh, right. Okay. Yeah.
I came out of the womb typing. So
who knows?
Who knows? So Gen 1 versus Gen 2. So both 2012 and 2016 support Gen 1 and Gen 2. Gen 2 supports more features. It's a UEFI-based VM as opposed to a BIOS.
So the secure boot thing we talked about before.
It does still support PXE and all those functions, but you should, whenever you can, make a Gen 2 VM. Okay, that's just the rule of thumb. Gen 1 is for backward compatibility. Gen 2 is the way forward. Both operating systems support both VMs. Can you convert from one to the other? There is no supported path that I'm aware of. We were discussing this during the last break. There are some scripts that are on the TechNet Script Center, or it's escaping me right now, Codeplex. That will take a VHD and convert it. Bear in mind that you're going from an IDE-based boot to a SCSI-based boot, so it involves editing the BCD database, a lot of stuff that has to happen. You can, with some of these unsupported scripts, switch a VM from Gen 1 to Gen 2, so rather switch the VHD from Gen 1 to Gen 2 so you can recreate the VM, but there's no way to go back from Gen 2 to Gen 1.
Okay.
And then the other question that has come up extensively is Fabric versus Hypervisor.
Okay.
Hyper-V, and in fact any hypervisor, is a component of your Fabric.
Yeah.
In current nomenclature, the Fabric refers to all that which makes up your compute, makes up your storage, makes up your networking. That's the Fabric that services run on, and then workloads like applications and databases and whatnot run as services on top of the Fabric. And so, the way that the world is beginning to shift is you have Fabric administrators that do storage, compute, networking, and CPU, RAM, virtualization layer, storage layer, network layer, and you have service administrators that do applications and related functions. So that's the difference there. So with that.
Awesome, thanks for that. That's a great demo and great example of how really accelerating performance with VHDX on REFS. And that brings us to the end of the server virtualization module. So hopefully you found that useful. We covered a whole load of stuff. There's a lot that's new in Hyper-V, and there was a lot that was in there to start with for people who perhaps haven't kept up with 2012 R2 up to that point. In the next module, we're going to be looking all about storage, software-defined storage specifically.
Love storage.
He does love storage. So please join us in the next module. See you then.